Cool. Hi, thank you all for coming. Welcome to PyCon PL. I'm really glad to, it's my honor to open up the presentations rather. So I'm going to be talking about capability-based security today. So I'm LVH, that's my Twitter handle, that's my email, also www.lvh.io. The slides are already online. I'll be showing the link again at the end if you want them. So quick introduction. As Philip already said, so I do a lot of stuff for PyCon, the PyCon in the United States. The financial aid project, for example. So basically we pay people money so that they can come to PyCon because flying halfway across the world is expensive. I do a bunch of other stuff. I'm not really sure what I should put here. I'm a cryptographer. I did a thing called crypto101.io, which is basically a free introduction to cryptography. In that. And I work for Rackspace Managed Security. We basically take customer environments and secure them. So that includes like securing individual boxes, that includes network security, that includes a bunch of stuff. We're hiring, even in Poland. Actually, we have someone in Kraków who works for us. So if you're interested in getting started in security, talk to me after the talk. Now, most of the talks that I give are very serious. There's nothing really controversial going on there. It's all stuff that's, I hope that they're not boring, but there's nothing exciting. There's no new research. It's all well-known and well-understood things. So I talk about cryptography, where you don't want to be preaching new and exciting things. You want to be preaching things that probably work. To talk about distributed systems, again, stuff where you want stuff to work. You don't want, just experimental stuff. And then once in a while I give a talk in Poland. And my talks in Poland so far have been not so conservative. My talks in Poland have been controversial, off-the-wall, crazy nonsense most of the time. A couple of years ago I talked about, well, what would happen if we take that nice little multi-layer architecture thing that you have and then we turn it inside out and then we put a bunch of stuff, some objects in some SQLite files, and you put the SQLite files in S3. I'm sure it'll be fun. So let's just say off-the-wall stuff. And today we are in Poland. So this talk is going to be a little crazy. And so I'm going to be turning some stuff inside out, and it has all of my hobby horses, because we're going to be talking about information security, we're going to be talking about cryptography, and we're going to be talking about distributed systems. So without further ado, let's start by talking about auth. And there's a reason there's some blanks there, because I'm going to be talking about both authentication, as in who are you, and authorization, what are you allowed to do. I'm assuming most of you are familiar with GitHub. And what happens when you try and access a repo? So let's say that you go to github.com/racksec, that's Rackspace Managed Security's word, /secret. In order to render that page, GitHub first figures out who you are. Are you logged in or not? Are you anonymous, or are you logged in as a certain user? And then, assuming that it figures out who you are, it goes to check if you're even allowed to access that repo. So I'm talking about a private repository, of course. Now, this is a really common pattern that happens anywhere that you look across programming languages. You always have sort of the same idea. For example, in Python, the first step is typically, with authentication, you take some credentials. That can be like a password, two-factor auth thing, a cookie, whatever. And that turns into your identity. Let's just say username, pretty much. For example, in Python, that might be, I don't know, some WSGI middleware or whatever. And then later, you take that identity and you turn that into access. So then you figure out what are the things that identity is allowed to do. Now, what's wrong with that? I'm not going to say that that's fundamentally from a metaphysical, according to the universe, this is fundamentally wrong, because obviously we've successfully written a bunch of software and it kind of works most of the time. But there's two problems with it that I'm going to discuss. One is that it fails open, and secondly, that it's imprecise. So, if you talk about failure modes, let's say that the authorization breaks. So GitHub has successfully figured out that you're logged in user, but the logic where it tries to figure out whether or not you should be allowed to access that repository is broken. Now, there's two things that can happen, and one is fail close, where a legitimate user can't access the code. And that's problematic because it means that you probably can't do your job for a little bit, right? But that's not as bad as the alternative. The alternative is that an illegitimate user can access. the repo. But one of the reasons that's worse is because obviously the second thing is permanent. Once the code has been released ever, you can't go and take it back, right? You can't go and retract information that's been put on a paste bin somewhere, like it's up there forever and the internet never forgets. And failing open, in general, means that your software is going to be more fragile. Generally, when you get code execution, it's game over, right? Once you get code execution, you can do whatever code can do, which is everything. And actually, unfortunately, code execution is kind of common, even though it's sort of it's the be-all, end-all. Once you have code execution, like you're done as an attacker. I mean, but unfortunately, still a lot of people use pickle, sometimes with like user-controlled input. And apparently, not everybody knows this, but like deserializing a pickle, reading a pickle, that is arbitrary code execution. If I can get you to read a pickle, that means that I'm doing whatever I want on your Python process. There's all sorts of problems with weird machines. I mean, look, remote code execution is a well-documented problem. I'm not going to go into the fact that it exists. Just look at CVEs. There's plenty of them. Now, of course, what I just said isn't very exciting, because what I just said is that running Python is equivalent to running Python. Okay, great, sure, whatever. Now, the reason that I'm bringing this up is because I want to talk about whether or not it actually has to be this way. Is it absolutely necessary that we give essentially full access to pretty much every single system that we interact with? And how can we limit that? How can we effectively limit that? The other problem that I mentioned is imprecise authorization. And for that, once again, I'm going to use GitHub. I'm not trying to rant about GitHub. GitHub is obviously a great service. Now, has anyone ever used Waffle.io? A couple of people? Okay, so Waffle.io is this sort of Kanban board-y style thing where you move tickets from one column to another. Sometimes, basically, the problem is programmers often like to use GitHub issues. Project managers like to see Kanban boards. And usually the result is that programmers end up with Jira, and they're very unhappy. So instead, what Waffle.io does is it produces a Kanban board from your GitHub issues. So the canonical source of truth is still GitHub, you're displaying the information a little differently. So because you have to give Waffle.io access to your GitHub issues, what happens is like you tell it to link to GitHub, you click on link to GitHub, and then it goes to Git, and it shows you this screen. It says, would you like Waffle.io, would you like them to have permission to your repositories? And in this particular example, like I just asked Waffle, like, hey, you can have access to some of my repos, and it tells you that it can read your personal user data, specifically your email addresses. That sounds okay. It can see your public organizations and teams. That sounds okay, because again, it's public. And it can only look at your public repositories. That's good, right? No problem. So I'm one of those people who clicks on the thing to see what that actually means. And apparently what access to repository means is read and write access to code, issues, pull requests, wikis, settings, webhooks and services, and deployment keys. So basically everything. Now, I thought I was getting an issue tracker, and I can certainly see why the issue tracker needs to be able to write to issues. I don't really understand why an issue tracker needs to be able to see my deployment keys or, commit arbitrary code to my repository. That seems like a problem. Now, again, I'm not ranting about GitHub. This is not GitHub and Waffle.io's fault. If you've ever read the OAuth spec, which is the open standard behind this, like they just have this sort of like parameter, and they kind of suggest how you use it. But the bottom line is like if you use that spec and you do the obvious thing, then this is what you end up with, right? So they're really just doing what OAuth gave them. It's not really their fault, and they're certainly not the only example. And to prove that it's not the only example, I'm going to talk about something that I've worked on that's completely messed up, which is autoscale. So, and when I say completely messed up, like, I mean, it's tricky. It works, it's fine, it's safe, yada, 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 but, it was hard to get there. So autoscale is a Rackspace service. It manages groups of servers, and it scales a number of boxes up and down, and they're like attached to a load balancer, and yada, yada, yada. Sorry, I just forgot something from my intro. So, I've been told by the organizers that I get to give away a book called Black Hat Python. And I've read this book, it's actually pretty good. It's basically an introduction to hacking software with Python. Apparently I can't give it away with randomness. I can't like randomly pick a person because you need a license for that. because it's gambling or something. So the most interesting bug in my slides, so if somebody finds a bug in my slides, they get the book. If nobody finds a bug in my slides, the most interesting question gets the book. I get to decide which one's the most interesting, because otherwise, randomness again. So if you want a book, just make sure that you find like a misspelled word or something. Sorry, so back to autoscale. So autoscale scales on behalf of customers. So basically autoscale is an API, and you ask the API like, hey, give me 5 more servers, or give me 5 fewer servers, and it does that for you. But importantly, it should work as if the user did that directly, right? So for purposes of billing, like it doesn't make sense that you ask autoscale to give you 5 servers, and then you never get charged for those servers. That's not how it's supposed to work. Audit logs, like it's the user asking you to do something, so it should look like the user asked you to do something. And a variety of other problems. So if you want something to look as if the user did it themselves, what is the easiest way to do that? Well, the easiest way to do that, of course, is to impersonate the user and make sure that you have a credential that looks as if the user is actually doing something. Yes?
Is it the bad, as you say, that user did it themselves? Is it like English users did it themselves?
Yes! You have found a bug. Congratulations. This man is in the running for getting the bug. So, the easy solution is to impersonate them. And how do I impersonate a user? Well, admin credentials, of course, because there's this API somewhere in the back of the deep, deep, dark recesses of OpenStack. There's an API where you get to impersonate users. And for that, obviously, you need admin credentials. So suddenly, I am stuck with some radioactive waste, because suddenly I have to manage this ridiculous admin credential. I don't want to manage an admin credential. If this accidentally gets committed to the public repo, because autoscale Otter is open source, that accidentally gets committed to a public repo, then accidentally we've just given the entire world like backdoor root access to our entire cloud. That's a problem. Also, sometimes you want to be able to run that against the production cloud from a development machine or from a staging environment. Yeah, we have staging environments, like complete staging environments, but when you're operating at the scale of a large public cloud, like you can't duplicate that because it just costs too much money. And you can have a staging environment, but the staging environment doesn't always have exactly the same properties because, like, you're running under different load, sometimes you're running with different hardware, yada, yada, yada. So the second problem is that a lot of people want those magic keys, right? Because if you get that magic key, then because we're a hosting provider, you haven't popped Rackspace. You've popped all of Rackspace's customers, literally every single one of them. And I can't talk about who our customers are, but like there's some interesting customers. Like I'm sure it's not too hard to imagine that most public cloud providers probably have some customers that like their data to remain private. So basically, threat level Mossad, right? I am going to be Mossaded upon. It is done. I am dead. Next time that I try to go fly, like in an airport or something in the international area, I'm expecting SEAL Team 6 or the Special Forces to drop from the ceiling, put a black bag over my head, and I will never be heard from again. Literally, my only hope for survival is that in between the NSA, the Mossad, the FBI, the People's Liberation Army, the Central Intelligence Agency, and literally writing a bear, that they accidentally kill all of them, kill themselves before they actually make it to me. So literally my only hope for survival is incompetence or possibly just like a bunch of people killing each other. Not great. So let's talk about PS in the Sky. What do I want? I can tell you what I want. I want one API key per customer at least. I want limited use credentials, right? I don't want credentials that are valid forever and that are really, really hard to change. So I want to make sure that, let's say that if there's a bug in my software and an attacker figures out the key, I want to make sure that I know that it's only good to them for like 5 minutes and 2 uses. That's okay. I can live with that because we can find those cases and figure out how to remediate that. I want that credential to be trivial to rotate and revoke, right? If I figure out that something's wrong with that credential, I want to be able to publicly say, like, no, that credential is bad. It got owned. Like, it's actually China. Just don't pay attention to it anymore. I want to be able to say, not just, you can create any server. I want to be able to say, create the server with one of these flavors. So in OpenStack parlance, a flavor is like a server, how much RAM, CPU, etc. So what kind of server it is. I want to be able to say, image A or B. I only want to be able to use these specific images that the customer wanted me to use, right? It doesn't make sense that you can use a credential to load, let's say, some random Bitcoin miner's image. Like, no, there's absolutely no reason why Autoscale should ever even be able to create such a server. I only want to be able to do it in this data center because like we have different installations for different data centers. It doesn't make sense that you can use the key for the data center in Oregon in order to create a server in London or whatever. Like that shouldn't happen. And this is a really tricky one. I want to be able to delete servers, but I only want to be able to delete servers that I previously created through this wacky credential. I don't want to be able to delete any server, right? And this is also really useful, not just from a security perspective, but if there's a bug in my code, I don't want to accidentally kill like that customer's production load balancer because they're probably going to be unhappy about that. So there's some stuff that I want, and I'm not getting it. And in general, what I want is the principle of least privilege. So this is a concept from information security where you don't give X more access than X needs in order to do its job. So you don't give it more privilege, you don't give it more authority. And if you apply that to real life, like, I mean, we have a lot of situations where we act that way. Like if you owe someone 100 zloty, like what do? Do you just give them the stufka already, or like make a transfer? Or do you say, well, you know, here's my username and password to my bank, you go ahead and take the 100 zloty, I'm sure that you're an honest person. Now, even if that person is a friend, you don't do that. You don't, just by default, you don't do that because it makes absolutely no sense, right? Now, as I just said, the problem with the principle of least privilege is that our tools are imprecise, right? We don't say, here's some access to some issue tracker, here's an access to an issue tracker, and you get to do these things to these issues. What we say is, here's free read and write access to all of my repositories pretty much forever. And the reason that is because, or at least my theory, my hypothesis, I should say, is that authentication is the first-class object, right? That's the thing that we can talk about. It's the thing that's reified. It's the thing that you can, so for example, it's a username and a password. It's a cookie, etc. So those are first-class things. We know what they are. And authorization is just a consequence of that. So we can't do anything, we can't really do anything exciting there. So what I'm suggesting is that we turn that inside out. That instead of having authentication and then authorization as a consequence, that we turn authorization into the first-class object, so that you have authorization as a first-class object that you can talk about, and I can, for example, give you a thing that only lets you create that kind of server, or that only lets you delete a server after you've created it this particular way, etc., etc. And people have done this. So it's mostly in the academic field, but they're called capabilities. So they're first-class objects. They're precise. They can be attenuated. I'm going to talk about what that means in a second. They can be communicated, which means so basically I can give you a very specific authorization. I can give you the stufka basically, and they might be contained. So containment is, we're not going to talk about it too much here, but basically it means that you can prove that it remains within the system. So it's impossible for me to say, I can, for example, give it to you through OpenStack. Let's say that we're talking about in the context of OpenStack. I can pass you a capability through OpenStack. I can't email you the capability. That's useful for certain properties, but we're not going to go into that much detail today. And most importantly, they cannot be forged, right? So one of the problems, let's say that, if you think about a hypothetical Python interpreter, right, it's very, very, very easy to predict the IDs of objects. And also, it doesn't really cost anything if you get it wrong. So if you just want to figure out all of the objects in a Python interpreter, like you just call ID a bunch of times on some integers, and eventually you're going to see some stuff. You don't actually call ID, but you get the idea. So, and so it cannot be forged. That's a property that can be guaranteed by your system. Let's say that you are using an operating system where the kernel is using capabilities. That might be guaranteed by crypto. Most of the common applications involve cryptography, because that's much more interesting proof than, well, we hope that nobody ever gets a kernel code execution exploit. So I talked about attenuation for a second. So that basically means, like, if I have a capability that can do some stuff, I can produce a capability that can do less than that. So that's interesting. For example, let's say that from when you do your deployments, you might want a key that can, you might want a capability that can create servers in any data center. But then once you do a deployment, you want to make sure that each individual data center only has the key useful for that data center, if that makes sense. And object capabilities, which was the original title of this talk, is really just the idea of applying that to an object-oriented programming language. For example, in order to use sockets, like typically you need either the socket module or the OS module, and you need a reference to a socket, right? So what happens if you can control references to objects? If you can, for example, guarantee that a piece of code can't actually ever get access to the thing that they need to open a socket, well, then you know that that code is never going to do any network I/O because you just prevented the only way that it had to do network I/O. Other APIs, of course, notwithstanding, but you get the idea. If you can control access to what a piece of code can call, then you necessarily control what it can do, because as we talked about earlier, code execution is all you have. Now, of course, you could ask the question, can't we just fix access control? Why do we have to throw all of the stuff that we have right now away? I'm not sure. I mean, maybe we can. There's certainly a lot of problems that we can solve with classic access control. But the problem is that right now, access control is already a mess. So if anyone's ever used any systems with like very, very elaborate role-based access control systems, I remember from my personal history something that involved a gigantic heap of Prolog. It's a mess. I mean, I just said gigantic heap of Prolog. There is no universe where that turns out okay. So, and in particular, like, we have access control systems that sort of work, but most of the ones that are nice to look at, like the access control level that they have is like, well, you're either admin or not admin, right? There's not really that fine granularity that we were talking about earlier. And this is a sort of a dependently typed problem. I know if dependent types, is that something, anyone heard of dependent types? Cool, awesome. Way more people than I was hoping for. So basically, dependent types, if you've ever done anything like C++ or Java or something, you know how you can have like a list of integers? So dependent typing is that you could put values in those types as well. So for example, you can say, I have a list of 3 integers, or I have a list of integers that is between 0 and 100. And you'll see why this is similar. Because most access control systems, they express roles, they express classes, right? They have to be known ahead of time as well. Because, I mean, as we saw, you produce an identity from some credentials, and then the credentials go, the identity goes into the authentication, sorry. I'm really jet lagged, I live in Chicago. Everything has to be known ahead of time because you have to write the function that actually figures out what you can and cannot do ahead of time. So there's no way to sort of live update that or to live generate a capability that you previously didn't know that you were going to need. You need to adjust your software every time. So let's say that even if it has like, you know, a create servers and a delete servers role or class, and most of you have worked with access control systems, like this is not your average access control system. This is like way, 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 way better than your average access control system. But they won't be able to say things like, I can create a server with this specific image because there's like infinity images, and you can't really create a new role every single time that somebody creates an image because people create and delete images all the time. And especially being able to delete a server that was previously made that way, like that means that it's stateful, right? So I can create a server and then later delete that server. There's no way to express that in access control. You have to say things like, well, you can maybe delete servers that have this metadata or some other property, but like it's a complete mess, and you can't really very clearly express what you want, which is just after you've created a server, then you get to delete. There's no clear, simple way to express exactly that. And even if we settle for the fact that they're ugly, unusable, and imprecise, then I contend that roles are the path to the dark side. My argument for this is quite simple. Roles lead to Active Directory leads to anger leads to hate, and hate leads to suffering. Don't install Active Directory, please. And then finally, why would you want that, right? Because I've been talking about how some of these properties can be guaranteed by cryptography, and we'll talk about that in a second, why that is. But I want my properties to be guaranteed by cryptography and not pinky swears, right? And what I mean by that is twofold. First of all, we pinky swear that the authorization code will never have a bug in it. This is really tricky if you're Facebook and your authorization code is like 10-year-old PHP that nobody wants to touch, because if you touch it and you break it, then like literally the company's over. And if you can guarantee those properties by cryptography, that's obviously way nicer. So how do we do that? Well, easy mode is, of course, local. So let's say that you have a memory-safe language. You get this sort of like ASLR, like Erlang. Erlang doesn't actually have this property, but Erlang kind of goes there. So what happens with Erlang is you create a process, and then you can talk to that process. So you have the same kind of idea where you just talk to the process, and that essentially forms your capability if you manage to just contain the powers that something needs in a specific process over there somewhere. But as I said, we really want it to be protected by crypto and not pinky swears. So for example, there's an object capability system called Tahoe Laughs, so what it does, you can see my comment. So the way that it does it is, if you upload a file, this is a distributed file system, so think Dropbox, right? And if you update an immutable file, what it does is it takes the contents of the file, and it produces a read cap. And then you can hash the read cap to produce a verify cap. Now what does that mean? Well, the read cap is what's used to produce the encryption key for the file. And the verify cap is what's used to produce the is to verify the file and where the file is stored. So if you don't know if you don't know, for example, the read cap, then with the verify cap, yeah, you can figure out where the file is stored and you can check that it's still okay. But you don't have the encryption key, so you can't decrypt it. And this is what I mean with, this is guaranteed by crypto, right? We're not just promising that the code will behave this way. No, if you can break this, that means that you can invert SHA-256, I think, for Tahoe Laughs. And if you can invert SHA-256, there are way more interesting things that you can that you can do on the internet besides maybe see my vacation pictures. I have a personal project called IceCap, kind of the same deal. It's a little bit simpler. So also it mixes a secret, and from the secret it generates an index, which is a key. It's a cryptographic quality key. It's got 256 bits of entropy. If you don't have this secret over here, then you just can't compute what you need. And so the security property is basically dependent on the fact that you move the cap over there. So that means that your hosting provider, they can't read your data either because they don't have the necessary stuff. They don't have the key. They don't have access to your API key, and that's fine. So you don't have to trust that Dropbox isn't mining all of your data in order to be able to sell you better ads, or sell some publisher better ads, because they literally just can't read your data. So why don't we do this already? I mean, if it's so great, why do we even have this stupid access control stuff? Well, so there's a lot of alternatives. You have classic privilege dropping. You have POSIX capabilities, which are not actual capabilities for a variety of reasons. But you can limit an application to be able to, you can say like, oh, well, you need to bind to a certain port, for example. You have SecComp, AppArmor, SE Linux, then in BSD country you have Tame, which is a shiny new syscall. You have Secure Level, which is only like true. That's my favorite example because it's really nice. It helps, but it's got literally 3 levels, right? So if you can describe all of the capabilities that you need in your entire system as only 3 things, then Secure Level works for you. Otherwise, you might need something else. There's a lot of stuff, and that should probably tell you something. The fact that there isn't just like one thing and we just use that one thing and be done with it, the fact that there's 700 different alternatives and most people have not heard of more than, let's say, I want to say 2, like probably SE Linux, you've probably heard of SE Linux, you maybe have heard of AppArmor, but stuff like Tame is fairly arcane. And these are opt-in or de facto opt-in, right? Because for a lot of applications, even if you run on a decent modern distro, let's say that you run on Fedora, as far as I know, they still turn basically everything off for Firefox because it turns out you can't actually do anything interesting in terms of capability reduction to Firefox or it stops working. So all of these systems are very, very limited. And we do kind of already sort of use caps. I want to mention Capsicum because they are actually doing a cool thing. So Capsicum is kernel level capabilities for BSDs, but who's heard of Capsicum? Yeah. So there's a couple people, but obviously not everyone. Webhooks, I'm guessing most people have heard of webhooks. So basically you get a long URL, you go to the URL, and that lets you, I don't know, post something to an IRC channel or something. And this is exactly the kind of thing that I'm talking about. You don't want to give out, all of these credentials to all of these IRC channels, you want to be able to just say, look, here's the authority to post something to an IRC channel. That's it, done. That's the only thing you need to know. We don't actually apply these things consistently. So how many of you have some Python software running in production? That's a lot of people, I would guess, right? Okay. How many of those know that that software accesses exactly the resources that it needs? Keeping in mind what I just talked about is like, you know, exactly this image, exactly this thing. Okay, we're down to one, I think. One person, anyone else? Two, okay, no, three. So, handful of people, cool. How many of you have used object capability systems? Right, of course, those people who actually have it working yet, they're using object capability systems. And how many, so you're running them in production now. Right, okay, awesome, cool. I was not expecting that. I'm very happy about that. We've tried this. By the way, this is one of your last chances to find a bug in my slides. Otherwise, that dude is running away with the book. You want the book. It's a really good book. So we've tried this. We've tried this with a language called E. We've tried this with a language called Kaya, or Kaja, I guess it's pronounced. We have a bunch of operating systems that work that way. I just showed you Tahoe Laughs, which is a distributed file system that works that way. So we've tried this a lot of times. So why didn't it catch on? And there's a lot of really, really great features, right? These aren't just like these weird little languages in the corner, that like they have really awesome features, like you can prove certain security properties, you can prove that it's not going to accidentally fire the missiles. You can prove it's persistent, so it's, it's persistent, it's distributed all Erlang, so it becomes really, really easy to write your code for a large number of cores, large number of nodes. It's statically you can statically prove your code to be deadlock free, which is basically, if you've ever done import thread, then you can't do that anymore. And it didn't pan out, right? Because who's heard of these systems? I'm guessing it's going to be like the same 3 people that have ever heard of anything that uses object capabilities. And I don't actually know why it didn't pan out. I'm theorizing. I don't know this for a fact. It's really hard to do science on historical trends like this. But first of all, a lot of these pretty much require you to rewrite your entire thing. And nobody wants to rewrite their 50 million lines of Java or whatever. So that's a problem. Secondly, the only real, it looks from the outside, from a marketing perspective, it looks like the only thing that they care about is security. And security is just often not a priority. Like, people care about having cheap programmers. They don't care about having good software half of the time. So this is a very, very unfortunate economic pressure, but that's the way it is. So how can we do better? I think I made my point on this slide. I'm pretty sure the answer is UX, because all of these things are extremely difficult to use. Like, you basically already have to be a true crypto believer. People with like really long beards who go to conferences and talk about security stuff, like they use this stuff, but like most people, it just makes no sense. And I think that the big problem here is that crypto people are kind of screwing up. Like, if anyone has ever tried to use GPG, you know how bad crypto people have screwed up. And I realize this includes me. It's my fault as well. But by now, we've managed to convince most programmers that they shouldn't be doing cryptography, or not writing their own crypto at least. But somehow we haven't convinced all of the crypto people that they should stop writing like user-facing software because they're terrible at it. Most crypto software that we use is just has either really, really bad features, or it's impossible to use, right? Or it's impossible for most people to use. I'm sure that most of the people in this room can figure out how to use GPG. That doesn't mean that I can expect to just GPG email everyone all of the time, because it's a tiny, tiny percentage of the internet population. And the biggest problem here is that security is an echo chamber. We only talk to each other. We don't talk to other people. We're really, really bad at inclusion. I remember a couple of years ago, DEF CON, as one data point for people wondering why we have very few women in information security. I remember at DEF CON where literally all of the post-conference events were organized at strip clubs, except one, and that one was organized in a hotel suite with the promise of strippers. So maybe we're not doing too great of a job at being happy and inclusive and inviting everyone, and then maybe we shouldn't be too surprised when we wake up a couple of years later and everyone looks exactly the same and has exactly the same set of experiences. So basically the point of this talk is cooperation and diversity for the win. We want different expertise, we want more points of view, we want more experiences. And basically we need UX people. We need to convince people who actually understand how to get people to use software, who actually understand. And when I say UX, it's super broad. Like if you know how to write a command line tool, that's already better than most crypto people. If you ever tried to use GPG on the command line, like look at the man page, it's terrifying. We need more people who just know, people with empathy. People who understand how other people work, or in general, who care about how other people work. And right now we don't have a lot of that. We have a lot of people who write a lot of mathematical proofs, and that's useful, and that's super great, and we need that, absolutely. But we need a lot more.
Get some points.
What?
Get some point writers.
Yes, absolutely. So to wrap up, thank you everyone for putting up with my rant. I realize that most of it is like, everything we have is terrible. But I hope that there was at least somewhat of a positive side to it. Particularly the PyCon PL organizers for inviting me. Doing the work that I do for PyCon US, I can absolutely appreciate the complete utter state of terror that they must be experiencing right now. And this concept of, everything is on fire, nothing works, that's perfectly normal. That's every conference. So, they really, just, if anything, just thank them because they need it. And with that, I'm done, and I'm going to go to questions. Thank you. So if somebody has a question, raise your hand. I really want to say, because there's only one comment. So I want to, if your question is more interesting than the comments, you still get your talk. So if anyone really wants to get a question. Oh man, it's a person who has object capability stuff. This is good.
Have you ever tried to use Python with Capsicum? Because I think it's very difficult.
So I was going to say, it depends how you define tried. I tried pretty hard. To say that it actually went anywhere useful would be probably overstating the truth. So yeah, I think that's a perfect example of even people who actually try to use this stuff, it's just impossible. It's really hard. And that's one of the reasons that I'm glad that, so for example, when Theo DeVat, who was the person who pretty much founded OpenBSD, created Tame recently, I was really happy about that because, well, it's the main reason Tame exists is because we have stuff and it's not great, it's not very pleasant to use, and Tame is still not perfect, but it's way easier to use. So. Anyone else? If I can't see you, you have to yell. Okay, cool. Well, thank you.